Okay, let's do a couple of double replacement reactions. We'll just do a couple of them just to kind of get the idea. When you're doing double replacement, you have a cation and an anion, and you're going to switch places with the cations and the anions. So basically, they are just going to switch partners. Okay, so if I'm doing the predicting products of this, I know that my cation sodium is now going to pair up with sulfate, and the zinc is going to now pair up with the hydroxide. Okay, and that's just the basic. I did not bring anything over. There wasn't anything to bring over. So in this case, though, what I have is I have sodium that is a +1, and I know sulfate from our polyatomic ions is an SO4 -2. So I need 2 sodiums for every sulfate. And in this case, I kind of gave you a hint on this one that OH is definitely not going to be just one of them. There's going to be 2. Hydroxide is a -1, so I need 2 of those to make that a neutral compound. Okay, once I've done that, I'm going to add my things on the side. Now, again, in this case, since I have sulfate over here and there's no sulfur other than sulfate on the products, I can keep the sulfate together. It will keep things a little bit easier. In this case, I have hydroxide over here and there's no more hydrogens anywhere else, so I can keep that hydroxide together. I do not have to separate it. But I do have to make sure I put that subscript for that. That doesn't mean 4 of these. That means 1 SO4. Okay, so then I put my SO4 here, I put my sodium here, and I put my hydroxide here. So now I'm going to take inventory. I have 1 zinc, 1 sulfate, 1 sodium, and 1 hydroxide. Over here I have 2 sodiums, I have 1 sulfate, I have 1 zinc, and I have 1 hydroxide, 2 hydroxides. Okay, so really the only thing I have to do here is I've got to make sure I have 2 hydroxides going in. That's sodium hydroxides going in, so that's going to give me 2 sodiums, 2 hydroxides. This checks out, and my answer is 1, 1, 2, 1, 1 for that. What this says is 1 mole of zinc sulfate plus 2 moles of sodium hydroxide yield 1 mole of sodium sulfate and 1 mole of zinc hydroxide. And that's what that tells me as a chemist. Okay. All right. So the next one we're going to do is this potassium phosphate plus aluminum nitrate. And in this case, I have my cation, my anion, my cation, and my anion. So I'm going to switch AlPO4 plus K NO3. All right. So that's the skeletons. I did not bring that one over. I brought this one over because it's part of nitrate, this subscript over because it's part of nitrate. I did not bring this one over because it is 3 nitrates, not part of nitrate. Okay, it's telling me how many I have. So in this case now, since the phosphate is over here, there's a phosphate over here, no other phosphoruses, and there's a nitrogen over here in the nitrate and over here in the nitrate, but no other nitrogens. I can keep those polyatomic ions together. Make sure that when you bring them, you bring the subscripts of the polyatomic ions. Not this one is okay to bring, that one is not. And then we've got KPO4, Al, NO3, and I am going to balance this. So the first thing I have to do is take inventory. I have 3 potassiums, 1 phosphate, 1 aluminum, and 3 nitrates. So 3 of those, 1 of those, 1 of those, and 3 nitrates. And then I've got 1 aluminum, 1 phosphate, 1 potassium, and 1 nitrate. And the big difference I see is potassium nitrate, 3 of those. So I've got 3 and 3. So the answer to this one is 1, 1, 1, 3. And what it says is 1 mole of potassium phosphate plus 1 mole of aluminum nitrate yield 1 mole of aluminum phosphate plus 3 moles of potassium nitrate. And that's what that yields. Okay, I hope that helped. That is double replacement reactions. That is how to predict the products, and balance it.